So here, there are two forces here. One force is this 5 Newton, another force is 6 Newton acting on a mass of this angle of 60 degree. So basically, this is a mass, okay, and you are applying this is F1 and this is F2, okay. So find some angle 60 degree, suppose, okay. So from here, what you can do, you can find out net force of this F1 and F2 resultant, okay. So FR, you can find out how you will find out FR. So using the relation vector, use the concept of vector F1 square plus F2 square plus 2 F1 F2 cos theta. Using this relation, you can find out net force. You can find out net force. Okay. So what is the acceleration of the mass after 10 seconds from the instant the force started acting? Okay. So obviously, once you get the net force, mass is given, you can get acceleration. You can get acceleration. The mass is given, that is 1000 kg. That is 1000 kg. Okay. So see the calculation part over here. So F acceleration. Okay, so this resultant will come. This resultant will come root square root of 182. Square root of 182. I'll divide by mass. So answer will come 0.013. That's the answer. This is answer. This is answer. Moving for next question. Moving for next question. Moving for next question. So this is the answer. And you can do these questions. Okay, now if you understood the concepts. Yes, 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 yes. So next question. Is next question is a stream of water flowing horizontally with a speed of 15 meter per second. 15 meter per second. Rushes out of a tube of cross sections of this area and hits a vertical wall nearby. So what is the force exerted on the wall by the impact of water, assuming that it does not rebound? Okay. So it does not rebound. Rebound means what? There is no final velocity. Can I say if there is, it's not rebounding. So can I say final velocity is zero? Final velocity is zero. Everyone, everyone, everyone. So basically, so what information given you in the questions? What information given? Water flowing in horizontally with a speed of 15 per second. Okay, so suppose this is U. U is what 15 meter per second. U is what 15 meter per second. Okay, versus outer cross-section area. Cross-section area of the tube is that is 10 power minus 2. Okay, you can take care of it. And it hits a vertical wall. So hitting the vertical wall, hitting the vertical wall, hitting the vertical wall. Nearby, what is the force exerted by the on the wall by the impact of force? Okay, assuming that it does not rebound. Okay, assuming that it does not rebound. So basically, you have to find out the force. Okay, so options are okay 2500 Newton to 2250 Newton, 2000 Newton, and 1500 Newton. So if you come to the calculation part, so see. So you can keep this formula in your brain directly. We use this formula again include mechanics. So F is AB square D. F is AB square D. F is equals to A into B square into D. So see here, this is density is given already in 1000 kg. Density is given already 1000 kg. So you can put this formula 1000 kg per meter power minus 3. So you can use this relation 10 power 3. So you can use this. So you'll get force of 2250. Okay, F equals to AB square D. Clear, 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 correct, correct, correct. Apply this formula. Otherwise, you can do without formula also, but okay, go with formula. I will suggest you because okay, you will get answer faster. Yeah, next question. So the 3% is simultaneously applying force reverse. You see, basically what's happening, there is a simultaneously acting on a particular mass and there is a mass is and it is in equilibrium. So whatever the direction, three forces, there is three forces. We don't know the direction. If F1 force was reversed in the direction only, then the acceleration of the particle. Okay, okay. So basically, see, suppose this is F2 and F3. Suppose this is F2 and F3, and this is F1. Okay, suppose this is F1. Okay, so acting on a particle mass and it should question should give the directions, but not given no issue. So basically, if we think like this, F1 should be equals to F2 plus F3. Now, if I will apply F1, if I will reverse the direction of F1, so then will net force of what? Minus of 2 F1. Can I say think like this? Think like this? Yes or no? So if we reverse the direction, twice of force will come in the picture because it's in equilibrium condition. Yes or no? So question asks you acceleration. So once you will get the force, you will multiply by mass, you will get say you will get the okay acceleration. So answer will come minus 2 F1 by m. You can see the calculating parts if you want. Okay, so this equation is very important. F net equals to F1 plus F2 plus F3. So this concept is very important for J point of view. Okay, so if you okay targeting for J, so please take care of all these concepts. Okay, this will help you in solving the questions. Okay, yeah. So come this questions parts over here. So you will give the answer. I already have given you the answers. Yeah. Next question front of you. These answers we have covered minus 2 F1 by m. Next question is pin goes generally post in the same result. This case create P and Q pushes with the force 500 the fixed force. So basically, mass is given. Basically, mass is given. Mass is given. Basically, mass is given. You are putting the force this, and then the frictional force this. So add this force, and subtract this force, and divide by mass. You will get acceleration. You will get acceleration. Yes or no? You will get acceleration. You will get acceleration. 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 So this calculation part, if you do add it, so and subtract it, you will get 600 Newton. Okay. So, after subtraction of this is frictional force, so 600 Newton. We will divide 600 by 1200. Answer will be minus 5.meter per second square. Okay, moving for next questions. That's push. Yes, the answer is 0.5 meter per second square. So a balloon has 8 grams of air. A small hole is burst into which the air skips at a uniform rate to this. So see, after this question, balloon has 8 grams of air. So this is basically what mass. 8 gram you can convert into kilogram, whatever is your requirement. Okay, no issue in it. So what is we are doing? A small hole is burst. Okay, in it. Okay, so piercing the hole. So the air skips at a uniform rate. So this is what, and you can see carefully. This is what dV by dt. dV by dt 7 centimeter per second. What is dV by dt? Can I say this is acceleration? This is acceleration. So what is force is what? Force is what? Mass into acceleration. Force is what? Mass into acceleration. So mass and acceleration can be written as dV by dt because rate of change of velocity with respect to time. And since in the rate of 5.6, ignore 5.6 seconds for a second. Okay. For a moment, ignore this. Okay. So this average perspective or average question asking you average force. Okay. So now come to the options and calculation parts. This options okay available we have, and if we see, so this will come. Okay. This will come. Okay, so here we'll divide by t. So because this is 7 centimeter per second. Okay, so this is 7 centimeter per second. So if you consider time, so it will come 5.6. Okay, so average question is talking about average question. Question is talking about average question. If time is not mentioned, then directly okay, you can also use this relation because see the unit is what? The uniform rate unit is what? dV by dt. Okay, dV by okay. See dV by dt unit is dV by dt. So here V is centimeter per second. Okay. And 3 centimeter per second. So we need to put okay time. Okay, we need to put time. So putting time is important over here. Okay. So see, velocity is centimeter per second. Okay. If you take the unit of dV by dt, so it will come centimeter per second square because this is acceleration. Because this is acceleration, so you need to divide by 5.6. Once you divide, you will get the answers. Okay. Sure. So after calculation, it will come 10 to the power minus of 4 Newton. It will come 10 to the power minus of 4 Newton. Okay. Next question we have a body of mass quickly moving on a gentle surface with this comes to rest after 2 seconds. If one wants to keep this body moving on the same surface with a velocity 4 meters per second, the force required is body this in the questions mass is given, that is stupid. You can write the unit over here. Velocity is given 4 meters per second. Okay, and comes to rest after t is given 2 seconds. So after this 2 seconds, it comes to rest. Okay, after 2 seconds, it comes to rest. If one wants to keep this body moving on the same surface with a velocity of 4 meters per second, so the force required is. So first, what I will say. Okay, surface with the, if one wants to keep moving this 4 meters per second, so ignore this velocity. Okay, ignore this line for a second. Ignore these lines for a second. If you want to keep this body moving. So horizontal surface with initial velocity moving on horizontal surface with the initial velocity 4 meters comes to rest. The final velocity, what we can say, final velocity is 0, and this is u. So basically what? mv minus u by t. Can you think like this? Okay, so if you think like this and just come to the options first and then calculation part. So options we have 0, 2 Newton, 4 Newton, and 8 Newton. So I will okay solve this. Okay, so you can also go through this equation b equals to u plus 80. From here you will get acceleration directly because see final velocity is 0. So once we get acceleration, you can get acceleration by many means. Okay, or either directly you can apply the formula b minus u by t. So our answer will come 4 Newton means. So we'll go with option number 30. Yes. Next question is ship of mass is initially at rest pulled by a force of 2 newtons through a distance of 3 meters, assuming that the resistance due to water is negligible. The speed of the ship. See, and this question very beautiful question. This mass is 3000 kg initially at rest pulled by the force of this. So you are applying the force this. Okay, the mass is this. Okay. So from here, can you say the acceleration? can you say the excitation that the resistance due to water and the speed of the ship is okay rest. So see, from here you can find out acceleration directly. Acceleration directly. Once you get acceleration, see initial speed is rest. Initially is u is 0. So you need to find out b. Okay, you need to find out b and s is given that is 3 meter. S is given that is 3 meters. What we say b square equals to u square plus of 2as. U square plus 2as. U is 0. So u is 0. So once you put all these relations, you will get it directly. Yes or no? You can think like this. Okay. Otherwise, you can think by your own way. No issue in it. Okay, because all the information is given by the questions. Try to link all this. U is 0, b square. So b will come square root of 2as. So you can apply directly over here. So it formula will come like this: 2f by m into s. Okay, so if you want to create formula, you can use the formula. Otherwise, as I said, without using formula. So I wrote this formula just for the point of convenience. If you want to keep this formula in your brain, you can solve it using this formula directly. Also, otherwise you can go with concepts as already explained. So once you put all the formulas, all the values, so it will come root 36 meter per second. So we'll go with option number 4. Next question. A gun can exert an average force of this Newton against the bullet, and the gun fires 50 grams of bullets at a speed of 1 kilometer per second. Okay. So the bullet releasing capacity. So basically, question asking number of bullets. N is what? Number of bullets. N is what? Number of bullets. Okay. Number of bullets. N is what? Number of bullets. No issue in it. Okay. So basically, what I'm saying, total force I had already given in the question, that is 180 Newton. So this is total force. F is what? 180 Newton. This total force we are applying. No issue in it. Again, the bullet, and the gun fires 50 gram bullets at a speed of this. So from here, can we say momentum? Momentum is what? M into B. Because initially it is rest. Initially it is rest. So finally it is coming by the speed of 1 kilometer per second. 1 kilometer per second. Finally it is coming. So can I say from here that the change in momentum is what? B minus U. Change in momentum is what? B minus U. Oh. See, so basically, if you multiply by m, okay, if you multiply by m, you will get change in momentum. And see, whenever this question comes in front of you, so okay, this is the favorite question for JEE. So what do you do? Total force is equals to n times of change in momentum. If this concept in your brain, from here you will get number of bullets. So now come to the calculation parts. So this is the concept you should know. You should know, and just asking number of bullets. So see f and mb by t. So you will use this. From here you will get n is 216. Going for next questions. Okay, so body of mass and 2 pages initial speed, this force action on it 4 seconds in this is the force time graph, so kind of speed. See, basically what concept you have to apply over here. This change in impulse. Okay, impulse is what? Change in momentum. Impulse is what? This is ft graph, so you can find out this area basically. So if you will get the area f into t. The f into t is what? Impulse. F into t is what? Impulse. F into t is what? Impulse. And you already know wherever you're okay. So see, impulse is what? Impulse is basically what? Change in momentum. Change in momentum. Use this concept. Impulse is what? Change in momentum. Otherwise, also you can go directly, no issue in it. But if you know the theorem, it's easy for you because every year, by 2-3 years, JEE is asking one question from these questions, okay, concepts directly. Okay. So if you know, you can do it easily. So from here, what you see, I'm showing the calculative part first. Okay. So this calculation will come like this. Okay. So area, change in momentum, B minus U, and area you can use basics concepts, triangles and rectangles. You will get the areas, that is this one come 14.25 and change in momentum to V minus 10. So B will come 12.12. Yeah. Next question. 2 blocks of mass 3 kg kept in contact with each other. This question is very good questions. This is very good questions. You should know because JEE asking these questions again and again. So basically, this is in contact. So whenever question is asking on contact, just treat like this. This is connected with a string. So there is tension in it. There is tension in it on the same way as tension works between 2 blocks, on the same way contact force works. Okay. So basically, what I say, if there is this force is suppose contact force, this is C. So this is also C. Okay, and then again you can apply the Newton's law. You can write the equation of. So suppose if I'm writing equation, this if a force of 10 Newton applied on a larger block. So this is larger block. This mass is capital M. This mass is small m. I'm applying the force of 10 Newton here. So I'm applying the force of 10 Newton here. So basically, how to write the equation? 10 Newton minus the C equals to capital M into A. One equation will come like this, and C, and here also you are applying only C. So from here C equals to, you can say, a small m into E. So you can solve both equations, will get the value of contact force. This is very important concept for JEE point of view. So I'm showing you the calculation part. So if you solve this, so this acceleration will come out net force by total mass. So this is coming at 10 by 4 and FC directly you can find out from this relation directly. So because this will come, if you write the equation also, it will come M2 into A, M2 into A. So A is what? Fy M1 plus M2. So you'll get the answer. We get so answer 2.5 meters. Next, moving for next question. Stone released from the roof of an elevator going up with an acceleration. This is the acceleration of the stone after release is. See, basically what is happening? What is happening? If lift is going up, so release from roof of an elevator going up. So lift is going up. Okay, suppose lift is going up with an acceleration of 5 meters per second square. So if you fall something, so there because of free fall, their acceleration will be g, means their acceleration will be 10. So basically, what you have to do here, you have to apply the concept of pseudo force and reverse the direction always. So this is 5 meters per second square. So basically, this will come in downwards plus of 5 meters per second. This is the concept of pseudo force. Okay. So you add it, so it will come 10 plus 5, 15 meters per second square. So basically, it's lift is accelerating in upward directions. You have to reverse the directions. You have to reverse the directions and you can add it. Okay. So it's a concept of pseudo force. Okay. You should know it. Okay. So stone is dropped from the roof of an elevator going up with an acceleration 5 meters per second. Acceleration of the stone after the release is. After the release is stone is released from the roof of an elevator going up. Lift is going up. Lift is going up. Okay. Lift is going up. So see here. So so body is released. So on the body there will be acceleration of okay g. Okay. So this okay. So see, correct this option. This is okay wrong. Okay. This is wrong. This is wrong. This is wrong because a stone is released from the roof of an elevator going up with an acceleration of 5 meters per second square. The acceleration of the stone after the release is, so it will come okay 9.8 plus of 5 because pseudo force will come here in picture. So it will come 14.8 meter per second square. So we'll do the correction over here. Okay, because accelerations you have to assume the pseudo force. Okay, personal mass discretely to the change in the current weight of the mass when the molecule moves up with acceleration 2 meters per second, then down. So 2 meters per second square is okay. Okay. See, in this question, again, you have to apply the same concept. A person of mass is given that is 60 kg. No issue it. Okay. The change in apparent weight of the person when lift moves up with an acceleration 2 meters. So when a lift is moving up with a 2 meters per second square, so you have to apply pseudo acceleration in downward direction, that is 2 meters per second square. So if I will add with the 10 acceleration due to gravity plus 10, so it will come 12. Okay. So this is what 12 meter per second square. So now 12 meter per second square is downward acceleration. Okay, no issue in it. Mass is 60 kg. So change in apparent weight. So first, in this situation, what is weight? In this situation, 60 into 12. Okay, so you can solve this, you will get the answer. And in next case, the person when the lift moves up, okay, with the acceleration and the down with the acceleration, with the same acceleration, now lift is moving down. So when lift is moving down, so you have to apply pseudo acceleration up direction. Okay. So if pseudo acceleration will come in up direction, that is 2 meter per second square, 2 meter per second square. So it will subtract. Now it will subtract means 10 minus 2. This is 8 meter per second square. So in next case, it will come 8 meter per second square. Okay. In next case, it will come 8 meter per second square. And then you have to multiply 60 into 8. It will come 480. It will come 480. It will come 480. And then very important concepts. It's anyone can apply over here. So you'll apply the relations, you'll get D plus A, this weight to difference will come equal to 240 Newton. Okay, we're moving for next questions. Okay. So this question is very important. Okay, learn this question, how to solve this question. M1 is 10 kg, M2 is 4 kg, M3 is 2 kg. The acceleration of the system is. So basically, if you focus on the system, so M1, so M1 is here. So this side M1 into G. this side tension, this side tension. This is completely block. Okay, no issue in it. So this tension is T, so this tension is also T. But if this is T1, this is T1, so this is what, T2. Can I say this is T2? If this is T2, so this is also T2. Okay, and this side, this is what, M3 of G. This is what, M3 of G. And because of this M2, this side will come M2G sine 30 degree. M2G sine 30 degree. Okay. So question asking the acceleration. So you can take acceleration this side also, you can take acceleration this side also. Then you can write the equation, you will get the answer. So M1 is given, M2 is given, acceleration of the system. So question we have options, this and this. So from here, I'm showing you the calculation part. Okay, so M1, so first equation will come 10G minus T equals to 10A. So I'm writing equation for this. So I'm okay, taking acceleration here. So basically what, M1 is 10, so 10G this side 10 T minus T equal to 10 into A. This is first equation you have to write. This is first equation you have to write. Okay, and for two, if you see the second equation, so this is what, T you can write T1, no issue, T1 and M2G sine theta, T1 this side T1 plus M2G sine theta. This is very important concept if you understand what I'm saying. And opposite side what, T2, opposite side what, T2 equals to mass into acceleration. So like this you can form the equation. I explained all the concepts. No, it's a conclusion part, so you can form the third equation as well. So once you form the third equation, it will come like this, M3 into A, and you will solve this. So after solving, so answer will come like this. Acceleration is 5/8 G. So answer key is third option. Answer key is coming third option. Next, we are moving for next question. The acceleration of the M1, M2, A1, A2 are A1 and A2. See, in this question is important. This acceleration is A1 and this acceleration is A2. Think if this will move X, if this will move X, this will move X. So can I say this will go down, this side, this will go down, this will go down, this is X by 2, or what? If this is moving X, so this will take X by 2, this will take X by 2, yes or no? So suppose if you want to move 10 meter down, so you need 10 meter of string this side also and 10 meter of string this side also. Can I say we need from this side 20 meter of displacement? Think like this. So think like this and try to create the equations. Once you create the equations, you can solve it easily. Okay. So question is saying, see, so directly question is easy, very easy. As I said, the question asking A1 and A2. Take care, M1 is A1, M1 is A1 and M2 is A2. It's easy questions and very important and conceptual questions. Very important and conceptual questions. Okay, so if you should know how to solve the questions. Okay, so basically what you observed. So A1 will come what? Twice of A2. Basically what is the meaning of this? Means A1 is double of A2. Can I say? Because this was coming what? X by 2. So this is coming on X. This needs to come X. Okay, so this acceleration is half. Can I say? Yeah, A2 is half of A1. You can also say this. Yes or no? Yes. Okay, so basically A1 is coming to A2, A1 is coming to A2, A1 is coming to A2. Okay, this is very important question for J point of view. This is very important questions for J point of view. This is very important question for J point of view. I solved here, so no need of this. Okay, I already did all this. Okay, so you have also done. Okay, somewhere also all this. Okay, this answer case. Yeah, next one. So their mass 6 kg, two objects of mass 2 kg and 3 kg are connected by a light string going over a light instrument fully clamped on the top of the inclined plane. In a study, the object of mass 2 kg hanging vertically and the other object is to be inclined plane. Other object is on the inclined plane. The acceleration of the system of the two masses is question asking you the acceleration of the two masses. Again, this question is easy. You can just create the equations and you can solve it easily. So basically what? If you see the questions carefully, hanging mass is what? Okay, two object of mass is disconnected on a light stream. Okay, over a light. Basically something like this. Okay, suppose something like this. Okay, something like this. This is fully okay, and this mass is suppose what? This is this mass and this is mass M1 and this is mass M2. Can I say? See, clamped on the top of the inclined plane, the object of mass M2 is hanging. So this M1, okay, object of mass 2 kg is hanging. This is hanging, okay. and other object is on inclined plane. So other mass is 3 kg. Okay, so this is inclined plane. So this is supportive force. So that you can directly say m1 minus m2 sine theta, or you can say directly m1g minus m2g sine theta, m2g sine theta divided by total mass m1 plus m2. So this question is very important for J. Okay, and this is a good level of understanding required to solve these questions. Okay, so you can solve these questions with the answer. In the problems, the tensor. So question asking the tensor, again, you can get the relations. Okay, you can apply the relation, or otherwise you can apply these relations. Okay, because all of you you know this relation. Or okay, you can apply this relation as well as if you want to go with the equation, you can solve the equations as well. You will get the answers. Okay. Choice is yours. How you want to solve it, you will get the answers. You will get the answer. Okay. Yeah. Next question. We are moving for next question. So how can you lower a 100 kg body from the roof of a house using a cord with a breaking strength of 80 kg without breaking the rope? Okay. So total mass is 100 kg of the body. Okay. See, total mass is 100 kg. So basically what? Because of mg, it will come 100 of g, 100 of g, 100 g. G is what 9.8 or 10. Okay. Breaking a strength is 80 means basically no upper force is this is suppose this force is F weight that is equal to weight, and this is a string is what breaking a strength T. So this is 20 gram. Okay, 20 grams. So acceleration will come what? Acceleration will come what? 20 by 20 gram. Okay, divided by mass is what? Mass is 100 kg. So divided by 100, this will come 1.96 meter per second square. So if you know, you can solve these questions like this easily. So if you understood, answer will come 1.96 meter per second. This is very, very important questions. Force applied on the one end of the rope in the direction of its length, and away from that end, the tension in the rope at the distance L from the end is okay. This is very, very good questions. In the following question, a straight rope of length L is kept on a frictionless. See, this is frictionless horizontal surface. So there is a rope of length L. Okay, no issue in it. A force of F is applied to one end of the rope. So I'm applying the force F this side, okay, in the direction of its length and away from the end. The tension in the rope at the distance L. Question asking you at length L from this end, what is the tension? What is tension? Understood. So basically, you don't have to worry. You have to just apply the concept. What is, if I will ask you total acceleration, what F by m? No issue. M is total mass of this. Okay? Total mass of this, yes or no? So if I will ask you break this into two parts, so this is length is L, and this length is what? L minus of L. L minus of. Do you agree? This length is what? L minus of L. So if lambda, suppose if I say lambda, because it's a string, okay, so lambda is mass density. So can I say what is the mass of this? Lambda into L. Lambda into L. What is mass of this? Okay, what is mass of this? Lambda into capital L minus of L. And what is total mass? Lambda into capital L. You use this relation and solve it. I'm showing you calculation part. You can solve it easily. So again, this question is very important. So if you know the concepts, you can solve it. So it will come like this: 1 minus m by m. So as I said, because mass is proportional of length. Mass is proportional of length because using lambda L. Lambda is constant. Whatever is this density or either the density of area or volume. Okay, water. Okay, so this will come like this. This is very good questions. Okay, so this is very good question for J. Okay, so now we are moving for next question. This option will come like this. Okay, next we are moving for next questions. Okay. So next questions we have the average force necessary to stop a hammer with a momentum in intensity. This is very easy questions. This is very easy. Average force necessary to stop a hammer with this Newton second momentum. So momentum is given what? 25 Newton second. Okay. So this 0.05 second. If you so force is what? Rate of change of momentum with respect to time. Rate of change of momentum with respect to time. So if what I'm saying, so speed in the Newton is this. Okay. So necessary to stop a hammer with 25. The average force necessary to stop a hammer with 25. Momentum is given, and time is given. So you can get the force from here directly. Yes or no? Tell everyone. So basically, you need to apply those. Force is rate of change of momentum with respect to time. Force is what? Rate of change of momentum with respect to time. So I'm showing MB is directly given in the question 25. You will divide by time. You will get force is equal to this 500 answer. 500 answer will come. Now we are moving for next question. A small sphere of mass. Small sphere of mass is kg. Moving with the velocity this. collides with a smooth wall and returns with the velocity this. So basically, see, initial speed is what given, and final speed is what given. The magnitude of impulse received. So mass is given. Okay, so what is impulse? What is impulse? I already told you. Impulse is what change in momentum. Impulse is what change in momentum. Impulse is what change in momentum. So you can easily apply the relation md minus u. You can find out momentum, change in momentum. Okay, so this is a very good question. Again, good level of questions. So if you understood the concept, you can do it easily. So this v minus u collision smooth returns with the velocity. So basically, why we are adding it? See, you are going with u speed, okay, and returns with v speed. Okay, so if you see the difference, u minus of this is what minus of b. So it will come u plus of b. That's why we are doing here m u plus b. Clear, 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 this b plus u, this. So impulse will come this of 10 root 5. From here you can say impulse is directly 10 root 5. Okay, notion it. A man and a cart move towards each other. Okay, the man weighs this kg and cart is linked. The velocity of man is this kilometer and that of cart is this. So when the man approaches the cart, he jumps onto it. Okay, the velocity of the cart carrying the man will be. So see, basically in this question, you have to conserve the momentum. You have to conserve the momentum simply. Okay, conserve the momentum simply. So m1 u1. So cart opposite direction. That's why I'm writing minus m2 u2 because moving in opposite direction. That's why I'm saying minus m2 u2. You can apply create the formula like this. You will create the formula like this, and after this you can create the velocity from here directly. Okay, so next we are moving next questions. So this KG-600 rocket is set for vertical firing. If the exhaust speed of the rocket is this, and then the gas ejects per second supply thrust need to overcome the weight of the rocket is okay. And the gas ejects per second supply thrust. So basically, what question is asking rate of change of simply so easy question. Rate of change of moment mass with respect to time. So this is what B. Can I say B? B into dm by dt. B into dm by dt. Can I say? And this is what? Okay, force. This is force. Yes or no? So force rocket for vertical. This the question is asking you what this dm by dt simply dm by dt. And what is the force? 6,000 kg. So 6,000 into okay this vertical was just speed of this 6,000 into g. Yes or no? So from here you can find out force and you can find out okay then gas ejected per second dm by dt. Okay, so mg u dm by dt. You can apply this here. You will get answer 58.8 kg per second. Next, we are moving for next questions. This ground is rocket for vertical firing. The exhaust speed is this, the gas and upward acceleration this of this. So this in this questions, what we do, as we say, see, this is upward acceleration. When the question give you upward acceleration, so in this case, what I'll say, this is force. This is force. Yes or no? This is force you are applying. Yeah, suppose this is force you are applying. Yes or no? And gives an acceleration. This the amount of gas ejected per second in rate. Okay. So basically, you have to take the difference. So this is this. M, okay, this the amount of gas ejected per second means V dm by dt, V dm by dt. This one is V dm by dt, and this is what mg, and this is what mg, V dm by dt, mg, or this is what total mass, okay, total mass into acceleration. So basically, what you need to do, V dm by dt. This is upward force minus of f. F is what? Because of weight equal to net force. Net force is what? Mass into acceleration. Net force is mass into acceleration. So you use these concepts, you can solve these questions. So see here, so relation will come. So here we are writing directly. Otherwise, you can go with like this. Okay, again, you can, as I said, this is what mg. You can write this minus u dm by dt equals to what? Mg u dm by dt equals to ma. Okay, ma, or you like this, so you can say minus of ma, because basically what equation we made? M d u dm by dt minus of mg equals to m into a. See, again, question can play with you here m also, because here you have to use the mass carefully. Okay, if any extra mass given in the questions. Okay, so basically, right now, no other information talking about mass. Only one mass is given. This, and the question asking rate of mass. This. So no need to worry. No need to write capital M plus small and something like this. Okay, so you'll get the answer from here. So what answer is coming? Coming. The embedded is this kg per second. I think this is one of the best questions. Okay. In the exams, question comes here. Next question is, when a horizontal force of 10 Newton applied on a body just begins to slide on a rough horizontal space, the horizontal force of 5 Newton is applied on it, then the frictional force acting on it. So basically, horizontal force of 10 Newton applied on a body, it just begins to slide, means this is what static friction. This is what when just begins now, this is static friction, just begins on a rock horizontal, so this is static friction. If horizontal force of 5 Newton applied on it, then friction force acting on it is this, is because static friction limiting value is this, and you are applying the less than limiting friction. You are applying less than limiting friction, so force will be equal to your applied force. Friction will be equal to your applied force. Yes or no? So I had mentioned you the calculated parts. Answer will come 5 Newton only. So answer will come 5 Newton only. Yes or no? So I hope all of you understood. Next questions. The horizontal force required to drag wooden cube of side A on our horizontal surface is F. Okay, so there is a wooden cube of side A on the horizontal surface is F. Another cube of same wood with another side 2A. Okay, so wood is same. Okay, but side 2A, side is 2A, drag on same surface. Then the force required the cube drag with the constant speed in both the cases is. So basically, in first case, everything is same. So side is A, the wood force required to drag wooden for side of A when one of the surface F, another cube of same wood but of side to A, same surface, then the force required to the cube. So here basically I should mention the total mass. I should mention the mass. Okay. So both of the cases will be. So see, if I'm considering only area, so area does not depend on. Okay, force does not depend on area in contact. Yes or no? Area in contact, area on the contact of the surface. But if we will change the density as well, okay, then think, okay, mg will change. Mg will change means normal will change. Yes or no? Normal will change. Okay, so basically what it will comes 8 times. A will becomes 2A means 8 times. Okay, sorry, getting my point. So then mass will come what 8 times. 8 take 8 outside, it will come 8d of A cube. So basically initially it was daq, now 8d of aq. So if you apply the normal is what m into g. Now normal depending on mass. So if normal is depending on mass, okay, yes or no? So dragged with a constant speed. Constant means, okay, you have to apply the net force on the body 0. You have to apply the net force on the body 0. The m2 becomes 8 of m1. So force is directly proportional to mass. Force is directly proportional. The force becomes 8f. Okay. Well, this is a good question. So you have to know a number of blocks, each of mass is placed one over the other. The minimum force, the horizontal force required to pull the 8 block from the top without disturbing the remaining is a 10 Newton. Okay. So question is given you minimum horizontal force. Minimum horizontal force is 10 Newton. The coefficient static friction between any two blocks is, so basically number of blocks, each of mass 0.4 kg, 0.4 kg, placed one over other, placed one over other. And there are how many such blocks? 8 blocks. 8 such blocks. Yes or no? So coefficient static friction between two blocks. So question asks you 8 blocks and a top without disturbing the, so pull. See where we are applying the force. Minimum horizontal force required to pull the 8 block from the top. Okay. So from the top you have to apply the force. Okay. So if we apply the force from top side with different calculation and bottom side different calculation. Yes or no? So basically what, if you see this, I drive the relation over here. If we have 8 blocks, its relation comes from top side. For this is valid for top side, it comes 2n minus 1 into mu mg. 2n minus 1 into mu mg. So here, how many blocks? 8 blocks. So 2 into 8. Okay, 2 into 8, 16 minus 7. Okay, it will come 15. Why? See, on upper block, only one frictional force F will come. But if you go to lower block, okay, 2 friction will come in picture. Okay, 2 friction will come on picture. Each block there will be 2 frictions. Yes, you know. Each block there will be 2 frictions. Yes, you know. Each block have a 2 frictions. That's why using 2n minus 1 mu mg. 2n minus mu mg. So this is again good question. So you'll solve it. You'll get the mu is 1/6. Block of weight 10 Newton, rest on horizontal surface. The coefficient of static friction between block and the surface is this. Coefficient of static block in this surface and the coefficient of sliding friction is this. If horizontal force to extend on the block, the magnitude of friction force acting on the block is, see, block of weight is given 10 Newton. So from here, this static friction value is given 0.4, sliding is 0.2. So from here find out maximum value of static friction. What is maximum value of static friction? 0.4. And what is this? 10 Newton into 10. So you will get 4 Newton. Okay. And you are applying the force of 2.5. This is maximum value required to, okay, static friction. Before that, all the friction will be static only. Okay. Static only. So if static, whatever force you are applying, that is the answer. So answer will come 2.5 Newton. Okay. So next questions. Okay. A book sits on horizontal top of the car as okay. Accelerates horizontally from the rest. If the static friction pushes the car and block is over, no access to the car can have to book not on the slip. Okay. So see, a question not given you the mass, no. Okay, sits on the horizontal surface, the car acceleration horizontal, the static friction between top and the 0.4, the minimum acceleration of the car. Okay. You know, our decision options we have is this. So basically, what m is cancel out here because basically, if this is block, a small mass of this is mass of the book. Okay, so acceleration is same. Whatever acceleration of car, their acceleration is same. Ma. So basically, ma is what mu into mg because this is frictional force on this book. Okay, so cancel out. That's why I didn't give you the mass. No need of this. So acceleration will come mu into g. You already know mu. You already know g. You can put the values. You can get the answer. So I'm giving the answer key. So answer will come 4.4 meter per second square. Next question we are going, body mass displaced on horizontal surface, 7% kinetic force this, 4% steady friction this. If horizontal force to applied on the body, then friction force acting on the body will be horizontal force equal to 5 Newton. Okay. And horizontal surface having 4% static friction this and 4% steady. Again, same concept as I said, find out static friction, kinetic friction, solve this. So I'm telling you the calculation part. So this will come static friction is coming 10 Newton. So again, 10 Newton, static friction 10 Newton, applied force is less than 10 Newton. So again, the force will be okay equal to the applied force 32.5 Newton. So I hope all of you understood all the concepts. Okay, so if you have attended class anywhere, definitely you can solve all J questions easily based on these concepts. So definitely these tips and tricks will be helpful for your J preparations and it will boost your rank. So till then, thank you.